Yeah, I was about to check the latest updates, and as you can see, yesterday there was 2 pictures, 2 frames, and now they're gone. But we still have this one here. Let's check it out. Is there something here? Something interesting to see? I don't know what to make of that one, but it seems to be interesting. This is my favorite spot. This. And in the bigger scale it goes like that. There's always activity, always. And for me, this is really mind-boggling because we are spinning around the sun is spinning, everything is moving, but those are always there and always at the same spot. Always at the same spot. What's that? TR3b spinning around the sun. Let's go further. There was something was detected. "13 frames aren't that many." If you watch this area here, we have this white spot. Now we go a little bit, zoom out. Now watch. They're moving to that direction. Keep in mind there's a half an hour in between. Half an hour between those 2 pictures. Obviously, this one got really bright. When they get really bright afterwards, there will be left this kind of black shadow. Now something, this is what I saw before. We have this white thing here. This kind of a dent. Which is caused by something. Otherwise there wouldn't be anything detected or whatever, no dent, and you know. And obviously something from the sun hit the satellite, because that's why it looks like that, because this is disturbance. Rays hit the satellite. Let's take a screenshot, put up the contrast a little bit. Let's see if there's something to see. Contrast increase. Let's put it fully exposed, a little bit down. Maybe the brightness bit up and exposure down. Let's see. No. That's not that sharp picture. Here we have. This pixel is always here. Always. Funny looking clouds around the sun. UFOs. Probably. I don't know. Just sharing my observations with you. Probably. Or you can tell me what those are. I don't know. I'm just fascinated by the fact that they are at the same place. different shapes. And there's always activity there. Let's try again a little bit, increasing more contrast before it gets too pixelated or something. Yeah, you can't make that much out of that one anymore. But there's probably something there. I don't know. And if they are many times bigger than Earth, keep that in mind. Yesterday I made this one video about Uranus's atmosphere dissipating into space. A few minutes ago I was thinking about that. If Earth is also dissipating its own atmosphere into space, which could be quite possible due our weakening magnetic field, increasing sun activity and all this kind of stuff. It would be basically possible. So, if there's like less air on Earth, so it probably we could practice living with less air on Earth by putting a face mask in our face and breathe bad air, that we get used to it quicker. Just a thought. There's this kind of cloud in which this thing is. Yeah, think about that. Because after all, we are just one planet of many, many, many planets. And if you think about the similarities between Uranus and Earth, we are here. Plasmoids are huge bubbles of plasma electrified gas that are pinched off the end of a planet's magnetotail. The magnetotail is part of the planetary magnetic field blown back by the solar wind from the sun, kind of like a windsock. As plasmoids are pinched off and escape into space, they take ions from the atmosphere with them. This can even change the composition of the atmosphere. Earth has a magnetotail, as do some other planets. What's behind that link? Science, NASA, heliophysics. Like a windsock near Breezy Airport runway. Yes, the answer on magnetic identification employed. The model predicts very gradual transition in plasma and magnetic field parameters at the eastern and western edges of the magnetotail, but sharp transitions at the northern and southern edges. I haven't read that yet. But you can read it by yourself. I will put a link down there. Let's go to ISWA. Just wanted to show you something. Let's take this other one. Magnetosphere 9. Click on update. Then you push here 300, that's the max. 20, that's the max. Here, apply. Give him some time to think. And if you just watch at that picture here, those red ones are the closed field lines. They shouldn't really stretch too far out. Let's go back to the article. I just wanted to show you one thing. Entangled magnetic lines. This plasmoid was also different from some others. It had smooth, closed magnetic loops instead of a twisted internal magnetic field. This was a big clue pointing to how Uranus's atmosphere leaks into space. These types of looped plasmoids tend to form when bits of a planet's atmosphere are siphoned off into space. The researchers estimate that anywhere from 15 to 50% of Uranus's atmosphere could have been lost to space this way. That's more than even Jupiter or Saturn. Unfortunately, the observations from Voyager 2 are the only close-up ones we have so far. So, it's hard to tell just how much Uranus's atmosphere has been affected over its history. Which basically means they have no idea how quick it went, what was before, like what's the time frame of all that. I just wanted to show you where it was written about those entangled magnetic lines, but I don't find them now. I just wanted to show you again. These are entangled lines. Our magnetic entangled lines. Is that one of those bubbles on Earth which steals us ions and our atmosphere? Watch that. That comes from below, goes up, and this comes from above, and they cross. There's a whole lot going on. Time glitch. And I wanted to show you something else too. Now we have seen those entangled lines. And if you go here you can see the direction of the streams. Let's go here. 320. Just a short explanation. For all those, it's the same. Let's try to put them in some kind of... Yeah, it's really hard to do that with a phone. Let's go here. Just to explain quickly. That's the principle of those, it's all the same. Our sun is here. So, its energy blows towards Earth. That's our bow shock, this red line, which protects us from quite much all bad from the sun. Bow shock, bow shock. Here you can see this circle is where the satellites are. Here we have to zoom in. It's not that visible here. That's a satellite. That's a satellite. So they are spinning around here. Some of you may wonder, how is it possible that even though that the mainstream is that's the direction where the energy is coming in. That's the direction where our sun is. You see how the directions change? They go a little bit up and down. And sometimes they turn around totally. They go towards the mainstream. For example, here. They go that way. This goes that way. And you have to keep in mind that's a two-dimensional model of a three-dimensional world, so they can't really show if it comes towards you or it goes away from you, you know. I like to fly fish, and I have spent many hours fishing at a river, watching the river, a steady flow of an element which is really important to us, water. And if you know a little bit about fishing in a river, you know that fish are hiding behind or in front of stones, because that's where is the least stream from the river coming, so they can stay in a calm pocket of water which isn't moving that much. I wanted to share you this, or I wanted to share with you that one. That's about fishing, fly fishing. I like to fly fish. How to find trout in a river. You may think, what the hell has this to do with our Earth and our sun? But let's just listen to what he has to say.
Of reading the water and finding trout. Let's look at those basics, and also about how all of what you've learned about reading the water varies depending on what kind of river you're fishing. When water hits an object, the molecules that bump into it stop moving, which creates a chain reaction of molecules bumping into each other, so a cushion of slow water forms in front of an object. Trout can use this area of slower water to hold their position. As water flows around the rock, the hydraulic jump, or change in pressure, creates turbulence behind the rock. Because the bottom of a stream bed is not perfectly smooth, turbulence forms and the water slows down as you get closer to the bottom. The rougher the bottom, the higher this area is. So in streams with a rough bottom, trout have more potential places to live protected from strong currents. All other things being equal, a rough, rocky bottom will be more productive than a bottom composed of sand or bedrock. Current is also slower closer to the bank than it is in the center of a river because of friction between the bank and the current. And the rougher the bank, the more pockets of slow water that can hold trout. In very fast rivers, sometimes the water along the bank is the only place trout can hold and feed comfortably. Although turbulence slows the downstream progress of the current and forms pockets where trout live, you can get too much of a good thing. Where turbulence is so strong it forms large swirls in the current, trout are less likely to be found because it's just too much. Trout get pushed around by the swirling currents, and because these...
So, just think about that. Water is just one chemical among many others. Where was it?
can use this area.
Let's take a screenshot. Okay. This rock is Earth. The sun. Just for playing around. This rock is Earth. The sun is here. The stream coming here. There's a pocket of slower water in front of the stone and a bigger pocket of slower water behind the stone. There's a pocket in the front, pocket in the back. Here's our rock, our Earth. Same principle. You can stand on a river and watch how the water flows around rocks and all these kind of things. How it can do like that and it flows to the wrong direction and then it stays here and after a while it goes there. Particles are behaving a little bit different because if you watch a river, it's basically, you can't see underwater how the water flows there, but there it's like, it has to be a little bit more complicated in a river than in space, because in space there is no walls or whatever, like in a river, like with the river bank or whatever, but a stone in the middle of a river behaves, or the water around the stone in a river. If you watch the current, the main current and the current differences behind, they flow to the wrong direction, you could think. But it's just swirling around. And one thing is also, it can happen like here, siphoning into space, or siphoning. There's a big clue pointing how to use leak in space. Where was it where they used that word? Okay, I understand Uranus is like on his side and all this kind of stuff. but the principle is about the same. In late March 2020, last year, 1 year, not even a year ago, NASA announced that an analysis data sent back by Voyager 2 way back in 1986 has revealed another intriguing secret about this ice giant world. The planet's huge magnetic field appears to be siphoning its atmosphere off into space. Siphoning, or turbo, like in a car. If there is a certain amount of stream coming from a certain amount of direction all the time, for example in a pipe, imagine that would be a pipe, just playing, and the pipe gets in diameter smaller in one place. There will be a huge pressure built up here where is not that much space, so it will suck. That's why people have turbos in cars. Our magnetic field is weakening, everything starts to work differently than it should in order to keep us alive. So things are getting wacky more and more. And I wonder if this could be this kind of siphoning effect like we had heard from Uranus, sucking the atmosphere from Earth into space. I don't know. I was just wondering. We are getting schooled by using masks. We are getting used to use this bad air, which affects humans in a really, really deep part of their old brains, which is all about fear of suffocation, which increases the already high level of anxiety in society, because it's individually fed by putting your mask on.